Hello everyone, welcome to Algo-holic, the place where you learn not just the solutions but the thought process behind solving problems. Today we're solving the problem merge sorted array. We're given two integer arrays nums1 and nums2. They are in non-decreasing order. So an array that looks something like this, where the elements are sorted but there also exists elements that are repeated. We're given two integers m and n which represent the size of the two arrays. We're supposed to combine the two arrays and then sort them in place. Let's look at an example. We have m as 3. So let's take the first three elements from the first array. N is 3. So we take the three elements from the second array. We copy second array into the first array and we sort the first array. This is what we're supposed to do. Now, can we solve the problem by doing just this? Can we copy the second array into the second part of the first array and call the sort function on the first array? We can do this, and the time complexity of this would be m plus n log of m plus n, because it takes on average n log n time to sort an array. But can we do better? Can we come up with an algorithm that runs in linear time? We can't sort an array in linear time, but we can take two sorted arrays and merge them in linear time. This has already been done in merge sort, and I'll just show you how it's done. Let's say we have two arrays like this. Let's initialize two pointers I and j. Let's compare the values of I and j. Which one is smaller? The value at I is smaller, so I goes over here and the pointer moves over. Now which one is smaller, I or j? J is smaller, so value of j goes here, j moves over. Now I or j, I is smaller, value goes here, I moves over, and so on. So you'll get the sorted array like this, and the time complexity of this is m plus n, where m is the length of the first array and n is the length of the second array. So we're just traversing both the arrays once. But we're also taking extra space. So that is going to be m plus n as well. And in the question, they are asking us not to return any array, but just store the result in nums1. So we're supposed to copy this and store it in nums1, which also takes m plus n time. So this is going to be 2m plus n, which is still linear. Now, can we come up with a solution which doesn't take up extra space? Let's try to do the same thing, but instead of storing the sorted array in a new array, let's try to store it in the first array itself. Let's say we have an array like this, 1, 3, 5, and the dummy elements that are present in the example above. The second array looks something like this, I and j. So let's compare the values at I and j. I is smaller, so we don't have to move anything here. So let's move the I pointer over. Now the value at j is smaller. So we'll copy the value and move it here. What happens to the value at I? We don't want to lose 3, so we move 3 over. What happens to 5? We move 5 over. The zeros don't matter because they are dummy elements, so they can just be replaced. So the new array looks something like this. I pointer is here and j pointer is updated to here. Let's again compare I and j. I is smaller, so we don't have to move anything. Let's move the I pointer. J is smaller now. J moves here and 5 moves here, and so on. So the array is going to be sorted, but what is the time complexity of this? Well, the worst case scenario of this is quadratic, and I'll show you why. Let's say we have an array like this, 100, 101, 102, and 1, 2, 3, and so on. So I is here and j is here. Since j is smaller than I, move the value over here and all the values are moved towards the right. So if there are m values over here, that's m operations. Since all the values in the second array are smaller than all the values in the first array, that's going to be n operations into m operations, which is quadratic, because there are n elements there are n elements over here, and for every element all the elements are being moved over, and since there are m elements, that's going to be m elements moved over n number of times, which is quadratic. Now this is a bad solution, but is there a clue somewhere over here? If we don't have to do the moving around, this algorithm is going to be pretty good. But how are we going to achieve that? What are we going to do with the values if not move around? Well, if you look at the example, let's say the example is something like this, and there are zeros at the end, 2, 4, 6. So instead of starting the I and j pointer at the beginning, what if we start I and j pointer at the end? Now we don't have to replace the existing values, but we can just replace the zeros directly. So what I mean is that let's compare I and j. If whichever value is higher, instead of putting the values at the beginning, let's put the values at the end. Therefore, no moving around needs to be done. So let's see how that would work out. So I and j is higher, so 6 goes over here. Let's rewrite this as 6. Now j is pointing at 4, I is still pointing at 5. Now I is greater, so I goes over here. This becomes 5. I moves over. Now 3 and 4, 4 is larger, so 4 moves here. This becomes 4. Now j is pointing at 2. I and j, which one is larger? I is larger. So this one, which was here, becomes 3. So that's going to be 1, 3, 3, 4, 5, 6, 2, 4, 6. I'm just rewriting it. J is still over here. And I, which was here, it just got replaced. Now I moves over. Now 1 or 2, which one is greater? 2 is greater. So 2 moves over here. So this becomes 2. Now j is out of bounds. I is the only remaining element which is already in the correct position. Now we have the sorted array. Now what is the time complexity of this? We are just looping through the first array once, looping through the second array once. So the time complexity is big O of m plus n, and we are not taking any extra space. So this is the most optimal solution. Let's quickly code up the solutions. So we need to copy the second array into the first array, but we don't want to replace everything, so we skip the first m elements. After this, just sort the array. Yep, it works. For the second method, we initialize 2 pointers. Initialize the k pointer, which points to the index of the result. Then we have the result. We can start the loop while I is less than m and j is less than n. If the first element of the first array is less than the first element of the second array, we add it to the result. Increment the pointer. Do the same thing for j. And no matter what gets appended, we always need to increment k. There's a small edge case over here. Let's say we have an array like this. So this loop is only going to run for the first 3 elements. The last 2 elements are going to be left out. So we need to append this to the end of our result array. So for that, we need to run 2 loops. While I is less than m, result k is nums I. Basically the same thing as here. The same thing for j. After this, we just need to store it in the first array. That's about it. Yep, it works. Now for the last solution, we start the k pointer at the last index. We keep decrementing the index. So while m is more than 0 and n is more than 0, we check if the last value of the first array is more than the last value of the second array. If it is, we append it to the last index of the first array, which is where our result should go. Doing the same thing for the second array as well. As usual, decrement the k pointer. We have the same edge case here also, but in this scenario, we're starting from the end, and there will be a scenario where the first array's first elements will be left out. But if the first elements are left out, it's already in the correct position. So we don't need to change it. We need to append it only if the first elements of the second array are left out. Because from the second array, we need to append it to the first array. So that's why we need only one loop where while n is more than 0, nums1 k is nums2 n minus 1. Yep, that's about it. And yeah, this should be nums1, by the way. Yep. Yep, everything works. Let's quickly look at what the C++ code looks like. We have the k pointer and the while loop to handle m and n pointers. The values are appended to the end of nums1 from nums1. The values are appended to the end of nums1 from nums2. And the remaining values are added to the start of nums1. Java code looks almost identical, the same while loop, performing the same logic, and the remaining elements are added to the start of the first array. So that's about it. I hope you found this video helpful. Your feedback helps me make better content, so please share your thoughts in the comments below. I'll see you in the next video.